What you will see below is a thin film representation of the processes that go into the manufacturing of high technology aerospace quality resistors. My name is Arthur J. Devine, and I developed and worked on these procedures in the early 1970s.
Okay.
Below here, we have several generations of resistor television. Most people see these. The first one with the stripes on this is we call a mud resistor. It's just particles of conductive particles that were embedded in a Bakelite type of a plastic like that, and typically had about at least a 10% variation in the actual resistivity. Here, going into thin film deposition resistors, we have a ceramic core that had originally had a solid film coating on that, like you see here, but running the entire length. Now, the resistance was measured while a diamond wheel, pointed wheel, cut a spiral thread across here, and it automatically stopped when the required resistance to the nearest ohm was reached, like that. And therefore, with this method, instead of 10% values, we could make resistors specifically to within 1% of any number of ohms, like that. Compared to the carbon type resistors, this is a nichrome coating, is able to tolerate much higher temperatures than this. Now, the carbon film, which is a wonderful use of carbon, had a resistant coating, and these were done in a retort that was fueled by natural gas, and it was in an oxygen-free ceramic enclosure that rotated the ceramic in a mixture of methane gas and approximately about 1500 degree temperature that fused this by vapors to the ceramic core, which is very similar to the ceramic core, but the connection of this is that this is a nichrome alloy that was vapor deposited under high vacuum, and so it deposited on the cylinders that were all mounted on pins that went around like a carousel, and then the exact higher resistance was made by cutting this spiral thread looking like image here that's greater, and it stopped there. Now, if this had continued further, the resistance would keep going up. And if you notice that there's different widths of pitch, just like a finer thread, the higher resistance you were able to achieve. Some of these are very coarse compared to this. And so therefore, these would have a much lower resistance. And of course, the lowest resistance was the face value of the deposition, whether it was carbon or whether it was nichrome. Now, the final result was these were encapsulated. Here is one that didn't fill completely. We used semi-finished blanks. There's no point having the thread. This is one that didn't fill completely because it was injection molded while it was under 320 degrees below 0 Fahrenheit, which is the liquid temperature of nitrogen. And it was instantly frozen, and there was what's known as a thixotropic additive to the epoxy that, like a meringue, kept it its shape, as you see here, and till it sat on a tray, thawed out, and then at the room temperature, it cured enough so you could handle it, and then put it in at an oven that was 350, 400 degrees Fahrenheit to cure the epoxy, like that. Also notice here, this is actually gold that was deposited on the ceramic to make the joint between the lead and this, and then the nichrome was deposited over the gold, but there was a mask here that only made this gold ring that you see here, hardly more than a millimeter wide, like that. And that's the way it was terminated reliably using the benefits of gold deposition, which is just rendered as a vapor in the thin film process. Later, I worked on depositing microscopic thin films by a process known as sputtery. And that was a radio frequency that actually popped atoms from a target made of a certain material onto a workpiece that was arrayed on a platter that was very heavy molybdenum metal, so it wouldn't levitate during that exotic process. Do you have any questions about this that you'd like me to clarify?
I think I'm very clear on this process. And what is the tolerance that you can hold when you have the resistors, when you make these resistors?
Well, I said earlier, many standard components like these are about 10% resistance. The carbon films generally are down to about 5% or better, and of course you can get 1% if you do selection, but once you cut these spiral, it automatically comes to the exact ohm you want. So if we're talking about 350 ohms or 500 ohms, it's technically possible to get it within a fraction of a percent.
That's incredible.
Yes.
Okay, Dr. Devine, thank you for your time. Talk to you soon.
Thank you. Thank you for listening, and we hope we can solve your problems for tactics for an affordable future. Thank you.
Take care.